AI in Action is brought to you by Alldus International, covering your business's staffing, consulting, and networking needs. Our host brings you the leading minds in AI, sharing their story, their success, and their advice. Focusing on fast-tracking you to the top, AI in Action cuts through the hype to help you kickstart your data science career. To listen to the latest AI in Action podcast, head over to www.alldus.com/podcast or subscribe via iTunes, Stitcher, or Google Podcasts.
You're listening to AI in Action. I'm your host, JP Valentine. Our guest today is Tom Chittenden. Tom is the Chief Data Science Officer for Genuity Science. Tom, welcome to the show.
Hey, fantastic, JP. Looking forward to the conversation today.
Likewise, my friend. So let's start. Brief background of yourself. I know we could probably do a detailed interview just about the interesting things you've done in the past, but can you give us a quick background of yourself, where you first got involved in technology, leading us up to just before you joined Genuity?
So, yeah, JP, I'll try and keep this short. I hold a doctorate in molecular biology. I also hold a doctorate in computational statistics. How I came to AI in the biomedical sciences or the life sciences was really out of curiosity. So I was sitting in a graduate school class, back in the early mid 90s, just right after the advent of DNA microarrays, and was just absolutely fascinated with the potential questions that you could answer. At that time, we were looking at capturing the entire transcriptome, or the state of a entire transcriptome in a single assay. And so what stemmed from curiosity ended up growing into a passion, and then eventually a necessity. So there's two sides to the coin there. Ended up getting through graduate school, 2 postdoctoral fellowships, hold a faculty appointment at the Harvard Medical School and Boston Children's Hospital, but also have been working in industry here at Genuity Science, formerly Wuxi Nextcode Genomics. We started with a small data science team or bioinformatics team, and that has grown into a full-fledged advanced AI research laboratory where we are addressing, or in the process of addressing, what I believe to be the most complex system in the known universe, and that's human biology. And we are using AI to help us understand the rules that govern the underlying molecular constituents that drive cellular behavior and dictate phenotype. And where we're going with that is, if we can gain a better understanding of human biology, we're going to be able to more fully address human disease. And now, about 5 years later, we have published scientific evidence that indicates that the AI is not only capable of teaching us the rules that govern biology, but we have now integrated probabilistic programming and causal inference into all of our ensemble computational intelligence approaches that now gives us the ability to ask why, or what's driving disease. Not what correlates with disease, but what's actually driving disease. And we have evidence now that we are capable of deriving putative causal dependency structures within all of this high dimensional omics data that are actually reflective of the signal cascades, signal transduction cascades that drive cellular behavior and dictate phenotype. So it's just a very, very exciting time to be in the field.
So, and thank you for that, Tom. Look, I appreciate you giving us the background and talking to us about your own journey. But on Genuity Science, I think it's important to really highlight that the size of the problem that you're trying to solve and the impact that this could have to global healthcare. So you're utilizing AI machine learning to map the human gene cell system in the hopes of identifying the markers that cause all disease. Can you give us some insight into where the idea for this sparked and how it's evolved, and how you've been working on this and the steps that it's taken to get to this point?
Yeah. So, two things. Being in an industry position here, there's always a commercial aspect of this. And so, what we are doing is basically we used to refer to ourselves as a contract genomics organization. I think we're referring to ourselves now as a data insights company. And from a commercial standpoint, and this is not a criticism of the pharmaceutical industry by any means, but we are going after the means or the capabilities to drive more effective therapeutics. And in 2015, total sales in pharma was close to 1.2 trillion. 150 billion of that was spent on R&D, and approximately 75% of that could be directly contributed to failed clinical trials. And so what we're doing, we're building what I refer to as disease agnostic algorithms. And what I mean by that, they can be applied in any disease state. And what we are doing is that we are leveraging these AI techniques to build, at the end of the day, more effective or efficacious therapeutics at the end of the day. So we're partnering very closely with pharma, which is one aspect of our business. I believe that the single most important aspect of any drug development pipeline is the identification of drug targets, right? And we are defining causal drug targets that are not only associated, but driving disease etiology. And what we're finding that by applying these techniques, we are much, much more efficient in not only dividing or understanding the underlying biology, but then going downstream to building these therapeutics that are going to be much, much more effective. They're not going to associate with the side effects that a number of current therapeutics have or associate with now. So from a commercial standpoint, that's largely what we are doing in the AI space, but we are along that entire spectrum from discovery, looking at the 10 to the 60 universe of small molecules once we define an actual drug target, to looking at how we would build a therapeutic. And then once that therapeutic has been built, if you will, how do we evaluate drug efficacy in clinical trials? And what we're finding is the AI and the machine learning is just fantastically apt at streamlining this entire process. So the $2.2 billion that it takes on average to bring a drug to market across 10 years, we can dramatically reduce both time and cost associated with developing targets.
So this would be a fundamental shift in medication and the pharmaceutical industry as a whole, taking it from medications that will treat certain symptoms but have an insanely long list of side effects. And that's even before the billions of dollars in the 10 years before the drug ever gets to market. What you guys are doing is working on, pinpoint accuracy of treatment and drastically reducing the time spent of a drug trial and the money spent. So it really is revolutionary. Could you give us some insight into the AI and the algorithms behind all of this? Because you indicated in your intro that you already have signs that this is working. There's research to back this up. So talk to us about the development of these AI algorithms and tools, and because this is AI for good at the tip of the spear. And so it'd be great to hear about how this has evolved over the few years that you've been working on it, and then we can look ahead to where you expect it to go in the near term.
So yeah, I can talk about what works. And then what I also like to talk about, which is you don't get this from most in the AI machine learning space here because there's so much hype. I always like to talk about what doesn't work. And so what we are spending a lot of time on is trying to figure out how to make the things that don't work right now actually work. And this stems from, we're not only machine learning, it's statistical machine learning. So, and I won't go into the detail and bore everyone, all your listeners to tears with this, but it has to do with statistical optimization. The problem with machine learning right now, especially in biomedical sciences, is that you have these high dimensional omics data sets. And this is just the omics data set. And then it even gets more complicated when you introduce additional features such as clinical parameters or phenotypic parameters as well, is that everything in the human genome is basically correlated to one degree or another with everything else in the genome, or we wouldn't, this is how evolution or molecular evolution occurs. And so that really causes difficulty with established machine learning techniques, is that if you cut your data up and you train and test and you can find a signal in your data, if you were to do that again, like what we do, and we not only do it again, we do it 100 times over, because I've never trusted a single run of a single algorithm. We're running it multiple times with multiple algorithms. And what we're finding is each time that we do that, we find different informative features. And what we're trying to do is capture, with the state of the art right now, we're trying to capture that informative feature space. So from a biological standpoint, we can go downstream. So if you, as an example, if you find a group of genes that may be involved with inflammation, well, they're so expressed or regulated to agree that they all correlate with one another, trying to figure out what the actual driver of that specific disease is extraordinarily problematic. And so we work extensively with our academic collaborators then to experimentally validate what we find. And so our classification approaches, which is really identifying what associates with a disease, sets the stage for what we are doing with causal inference. Probabilistic programming is, can we find what is actually driving the disease that is more so than what is associated with the disease? And we're actually cutting through all of the noise within these high dimensional data sets, and we're finding that we are capturing so much biological variation within these data sets that they're actually reproducible. So one of the dogmas that exists in the machine learning field is that you do really well on a patient cohort that you are training and testing on, but when you get to a different patient cohort, these algorithms tend to fall over because they really haven't learned the underlying dysregulated biology. They're just picking out what's associated with the disease. And so what we've done, and I think we've advanced the field significantly, is that we are finding these causal drivers of disease. And where we really want to go with this, JP, is that Google has been doing this for quite some time. With GPS and Google Maps, knowledge graphs, they've been around since about 2012. We know how to get from point A to point B, right? But we don't know that at the molecular level in biology. And so by taking these causal inference approaches, we're actually building, very gradually, we are building these underlying, basically, it's a roadmap to human biology. And we're at the single cell level now. And so we're being able to stitch this together within individual cells of an individual. And this is going to open the door for looking at being able to robustly address rare disease states where we don't have large population or the access to large populations of patients that we can run population genetics or genomics analyses, that we can capture all of this biological variation, if you will, in a single patient. And then we've developed very robust advanced approaches that look at representation learning or transfer learning, and then go find that signature, or if that signature then exists in another patient that's been diagnosed with the same affliction. So where the field is going is just extraordinarily exciting right now. Even with the state of machine learning, the statistical optimization is still problematic. That's why we're looking at quantum machine learning and neuromorphic computing, or spiking neural networks. So I think where deep learning specifically is going to go, or the future of deep learning is going to be based on neuromorphic computing and spiking neural networks, which are, if you talk to most in the field, they would say that it's significantly more analogous to human intelligence or human learning than current deep learning topologies. So yeah, within the next 2 to 5 years, I think we're going to have significant advances, not only in the technology, but how to address human disease. I think it's going to cause or create a completely new paradigm in healthcare, especially at the single cell level, when you can diagnose an actual disease state within a single patient. It's really going to be it's really going to open the door to a lot of different approaches here in the near future.
Hearing you explain that is really helping to visualize the shift into sort of the combination of what we would have thought as science fiction, the science fiction aspect of what AI is capable of doing. But this is the building blocks of us getting to the point where we can start to realize some of those dreams around being able to treat illnesses instantly and pinpoint it. And what you guys are doing is paving the way, and it really is building for that, that shift in how healthcare works entirely. It's incredibly exciting. I spend a lot of my time speaking to biotechs and pharmas, and they're working to solve specific indications, whether it's oncology related or process for patient care. But this is a step beyond that. It's amazing to see what you guys have been able to accomplish. You said that you referenced there the Google Maps of the human genome. Last question for you. I want to talk about what's next, because you've already indicated some of the impact this can have. And you talked about where once we walk through that door, I want you to take us through that journey. Once we've fully mapped out the human genome and we walk through the door, what are you most excited about? What is the biggest impact that you can see that this type of technology can have?
Yeah, well, and I don't want to say, JP, it's another fantastic question. I don't have a crystal ball, but I have a very strong sense of where we're going. At the risk of fueling the AI hype machine out there, which is significant, I really believe that we are going to eventually get to the point. I don't know if it's, here in my late 50s, whether it's going to happen in my lifetime or not, but I really believe that we have started a journey where the AI is going to start teaching us the rules that govern biology. And eventually that will lead to this underlying roadmap, if you will, of normal molecular physiology that we can trace information flow through. Similar, with Google Maps and being able to track or to trace traffic through these networks, if you will. Where this, I believe, is going is it's going to eventually lead to the eradication, just not the point where we can address human disease, but actually lead to the eradication of human disease. Now, whether that occurs in my lifetime or not, I think that it's going to happen well within your lifetime, JP. I think that you will end up being around to see this as well. And I don't think I don't think I'm fueling the hype. I just have a very strong sense of this is where.
I don't think you are at all. I think the combination of your expertise, your credentials, but most importantly, the results that this work is showing already can give credence to the fact you've got some leeway to speculate because you're on the front line and you see what's coming. And for all of us who are going to benefit from this research and study, we're all excited to see it come to fruition. Tom, this has been amazing. I really appreciate you taking the time out, talking to me about yourself, Genuity, what you guys are doing, because it's not an overstatement to say this stuff is going to eventually change the world. So we appreciate the work that you do, and excited to see all the updates that come.
Yeah, JP, I'd like to sincerely thank you for the opportunity to talk about. I've got family members that their eyes glaze over when I start talking about this stuff. So, providing the forum to talk about this has absolutely been fantastic. And JP, you're a rock star, buddy. Thank you.
Thank you, my friend. Thank you so much.
AI in Action is brought to you by Alldus International, covering your business's staffing, consulting, and networking needs. Alldus offer an exec search program. Alldus can help you discover how data science and AI can transform your company. With our unrivaled network of C-suite executives and senior AI professionals, we offer retained search services across the US and Europe. Get the Alldus advantage. Become a member of the Alldus community and enjoy some of the following: AI meetups, Once a month, our community gathers to listen to some of the leading experts in the world of data science and AI. Our speakers come from all over the world, including Dublin, Boston, and Frankfurt. We also have our AI mentors. Our experts will provide mentoring to Alldus members. And don't forget our AI in Action podcast. Each week we have guests from all over the world talking us through their education, career, and more. Become an Alldus member and get the Alldus advantage. For more information and to sign up for our newsletter, log on to www.alldus.com. That's www.alldus.com. Alldus International, empowering through AI.